We're now going to start digging into the reactions of the chapter. Most of the reactions in this chapter are going to be with alcohols. And the first sort of category that we're going to look at is the conversion of an alcohol to an alkyl halide. In this video, we will limit the discussion to the use of HX as the reagent for this process. The functional group transformation that we're discussing is going to be the alcohol to the alkyl halide. And again, we're going to be using HX to carry this out. First, let's kind of compare and contrast the alcohols with the other functional group that you've been introduced to so far, and that's the alkyl halides. And obviously, they both have an electrophilic carbon. However, alcohols have a poor leaving group, so keep in mind that this would actually leave as hydroxide, which is a strong base, and we want leaving groups to be weak bases. Alkyl halides have a good leaving group because this leaves as X-, which is a very weak base. One major concept that's introduced in this chapter is how to make an OH group into a good leaving group. And so one strategy is to protonate, because if you say react an alcohol with some acid and protonate the oxygen, you have now made that into water, which is a good leaving group because it's a weak base. If you react an alcohol with a strong acid like the HX series, you're going to get an acid-base reaction between the lone pair of the oxygen and the very acidic proton. And so that's going to yield the protonated alcohol. Once the alcohol is protonated, there are a couple of different things that could happen to it. One would be the water could just come off as a leaving group and leave behind a carbocation. The other would be that a nucleophile could come in and attack this electrophilic carbon and displace the water. Let's first take a look at the fate of the carbocation that could be formed here. It has a couple of options. It could just get reattacked by the water, in which case it would just reform this species here, and so just kind of establishing some type of equilibrium, which is a non-productive route, and perhaps that's always going on in the background, but we are not really interested in that pathway. What we're interested in is the carbocation then getting attacked by a nucleophile to give a substituted product. So now we've shown that the protonated alcohol could either be directly attacked by a nucleophile, or it could decompose into the carbocation, which could then be attacked by a nucleophile. So now we're left with the question of what is that nucleophile? Recall that the first step of this reaction was to protonate the alcohol with HX. And so we have X- floating around in solution at this point, and X- happens to be a good nucleophile. So the answer to our question, what is the nucleophile, is going to be X-. In all of these reactions, the first step is going to be the proton transfer step to give the protonated alcohol and generate X-. And then the second step is going to be X- either coming in and attacking directly and displacing water, or the leaving group coming off, forming a carbocation, and then X- coming in to attack that carbocation to give a substituted product. Notice that the end result of either pathway is going to lead to an alkyl halide and also a mole of water. Let's talk a little bit more about these two different pathways that the protonated alcohol can follow. You can either go through a carbocation or direct displacement with no carbocation. Hopefully you're able to see some parallels about what you learned about alkyl halides a few chapters back. And based on what we know about carbocations, it makes sense that this pathway here would be followed by secondary or tertiary alcohols, and this is going to be an SN1 substitution. Whereas the direct displacement pathway with no carbocation formation is going to be an SN2 substitution, and this is best with either methanol or a primary alcohol. For example, if we have ethanol here, this is a primary alcohol. This is not going to go through a carbocation. The first step is always going to be protonation to yield the protonated alcohol in X minus. And then the second step in this pathway is going to be direct attack at the electrophilic carbon and simultaneous displacement of water as the leaving group. With the tertiary alcohol, this is definitely going to go through a carbocation. So the first step again is going to be protonation to make the good leaving group and generate X minus. The second step of this process is going to be carbocation formation, so the leaving group coming off. And then finally, the nucleophilic attack of the carbocation. These secondary alcohols, like something that you see here, would follow the SN1 path and so go through the carbocation.